Hello, welcome to the session today. Today we're going to talk about the digital thread, and actually this morning at the keynote, or at the panel more specifically, I loved it. It was about a lot of talk about the digital thread, the digital twin. I see Reimer out there, one of the panelists from this morning. So that was a great introduction to my presentation today. And we're going to talk about how the digital thread enables the manufacturing, that connected manufacturing enterprise, the model-based enterprise that you might have heard about. And we're going to get into some specific examples of how we do that. Okay. All this fascination is really, with the digital thread, it's really about leveraging 3D models. Is that we have been working for the last 40 years with processes that were really designed around blueprints and 2D drawings and sheets of drawings and rolls of blueprints. And we've laid out a journey, a plan to leverage 3D model content, not just in engineering, but throughout the enterprise. And we're still in that process of going from the drawings to that model-based definition to a model-based enterprise. So we'll be more specific about how we do that. I went too far. Okay. Not cooperating with me. Okay. So there is the model-based enterprise has been defined by aerospace companies to be a journey. A journey from those drawings to the model-based definition, the model-based manufacturing, to all the way to the model-based enterprise. And that is, along the way, we have more use of the 3D model, and we have more structured handover of that model-based definition from one department to the next in that digital thread. So let's talk about what does that look like. If my pointer cooperates. Okay. So the digital thread has become a requirement on DoD contracts, and is now being called out in a lot of the requests for proposals, because the DoD recognizes the potential of this information, the digital thread, the digital twin, and what it can do for productivity down the line. Along this progression of leveraging that 3D content, we go from the illustrations that are based on the 3D to 3D animations to augmented reality. I'm going to show you some examples of what we're doing there, which is pretty cool. Not only can we deliver this through tablets and layering that 3D augmented reality on top of the real product, but we can also do it through smart glasses. Smart glasses that will let us project a layer of virtual reality on top and give us things like work instructions without having to use our hands. And then input is done through voice. And all this technology is becoming really practical to deploy. But before we go in and show you those examples of what we're doing today, the leading edge stuff, let's take a step back and look at where we came from. We came looking at the manufacturing plant process and the product realization process, all the way from receiving to manufacturing, inspection, assembly, all the way out to delivering a product to the customer. We really designed the processes with a hands-off, over-the-wall mindset back many, many moons ago. But in many places, we still have that legacy of throwing drawings over the wall. Now it might be a 3D model, but still, engineering designs a product. In manufacturing, you go and figure out how to build this. We're getting more and more, we're moving away from that, but some of that heritage is still there. And the fact that the formats, the systems used here and systems used there are not the same and not yet very connected. And the feedback loop was heavy on quality engineers or middlemen here, liaison people talking to engineers. We didn't have a lot of the engineers working on the shop floor, especially in the bigger companies. Then in the 70s, we started bringing PCs into the shop floor. And we have things like CAM, like NC, control machines, SPC, a lot of spreadsheets, really, that we started developing for manufacturing. And in the 70s, we moved a little more from paper into using the computer and the PCs and leveraging them and more computerized programs, but still a lot of manual translation between the engineering content and the manufacturing content. So no direct way to take a CAD model and convert it to CAM, no direct way to convert it to an NC program, a lot of manual effort in between. So that means a lot of manual reconciliation and a lot of opportunities for errors. So what we want to do with the digital thread is take the next step, and you saw all those yellows and red zones. We want to turn them into green. And green meaning that the path of information between these support organizations and the shop floor is really a digital path of structured and parsable information that the sending system, the engineering system, can send information, and the receiving system, CAM, MES, inspection systems, coordinate machines can take that information, parse it, and use it to create the program to make a part, inspect the part, and the instructions to put it together in a way that we maintain associativity. Let's look at what those tenets would be in the digital thread. It would be the right information at the right place at the right time. That would be an important tenet for this process. Right? So not only can you get information by going on a computer and looking it up, but I shouldn't have to look it up and search for it and find it. I should be able to, because of my task, is all the information I need is linked to it right there at my fingertips. Data should definitely be entered only once, and that includes the geometry, that includes the specifications of the geometry. I shouldn't be, if there's a measurement, I should be able to drag it somewhere and say that's the basis for this inspection, not retyping that number and have a issue with accuracy, with unit of measures, and miss something in the translation. So the digital handover has to be structured, parsable, revision control. So we need to move to where it's structured XML, JSON, but some structure where we can tell that this piece of information is identified a certain way and is tied to a certain revision control in engineering, so that when we create the downstream processes, we maintain associativity to those objects. So the change control process is very important, that derived objects from upstream maintain associativity so we can apply changes quickly, especially when we're building a very complex product with thousands of parts, with 20 levels in the bill of material or more. We want to know that out of those thousands of parts, only these few dozens were changed in that last change, so we can focus the change downstream on those objects. So what's our solution for that? What we have found and iBase-t focuses on is adding execution to the product lifecycle management. So because that handover of information really starts falling through on the execution side on the shop floor. And that is an enabler to that real-time enterprise, all integrated, connected, all model-based. What does that look like? Well, that product realization process from requirements, supplier management, production to services in the supply chain. When we look at that process and we drill down into the different roles and what happens at the different sequence, the PLM processes are focused on design of how the product comes together, how the processes go together, simulation, validation. The ERP processes are really focused on planning, procurement, scheduling, and generalizing those buckets. And there's been a lot of progress in those areas. What we haven't had a lot of progress is on execution, and in a way that is linked. That is part of that digital thread. But the digital thread is not complete, and the PLM vision is not, the product lifecycle management vision is not complete unless we link all the execution. So that when we're doing things in the shop floor, we know that we're working to the right engineering level, to the right specification. So what does that look like? Well, so that's our product footprint, and if you want to know about it, we're at booth 309. So I'm not going to focus so much on the footprint. I wanted to focus a little more than that, but it includes supplier management of quality because specifications go into the supply chain, the manufacturing process, and maintenance, repair, and overhaul. So it's during the entire life cycle of the product, from requirements, supply chain, production, and MRO. It's the execution side on the shop floor where actually things get done. They need to get done in a way that it relates back to those requirements coming down. And that's where the digital thread, we're going to start telling you how it looks like. It looks like a thread. And why is it a thread? Is because we need to focus, the definition of the thread is really on the handover of information. So that handover of that product definition to inspection planning, to manufacturing planning, to services planning. And that handover needs to be in that structured, parsable manner. But it doesn't stop in the planning and design of the process. It needs to go all the way to execution because that data, and we keep talking about that data and the digital twin and all the actuals, needs to cross-reference to the definition. So how do we make sure that that product we built is built to specification? Sounds simple, but in very complex products that can, and with a lot of changes going down the line, that can get complicated. So what we've done is drill down on these definitions and handovers of information. iBase-t was recognized in 2014 by Gartner for being ahead of the curve in this area and fulfilling this vision. And a lot of that has to do because in aerospace and defense, which is one of our niche markets, this is very important. So let's look at that execution part and manufacturing first. It starts right with the definition. Sorry about that. We really need new batteries in this. Oh, this is really... Whoa! Hello? Right there, right there. Put me there. I'll take it from there. Okay. I'm sure we'll edit that out later. Okay. Production. You're killing me over here. Just when I got the rhythm going. Here we go. Okay. We're ready? All right. Okay. So we really start in the PLM system and the engineering definition and engineering bill of material to manufacturing bill of material. And some folks might want to eliminate one of these, but the fact is that we might rearrange a little bit the engineering definition for different type of manufacturing processes. And then we need to define how we're going to build it. The important thing is not to try to eliminate steps along the way. Well, that's important, but more important than that is to maintain associativity. So these arrows, so the thread, the digital thread, the arrows, the connections, that's the important thing. That as we move that information, we maintain a cross-reference back to the prior object. And the levels of associativity that we can have now with 3D content, with digital content, are not even close in paper. In paper, it was a document level association, and who knows the objects that we had inside, right? Just a sheet and a drawing number. That was about it for our cross-reference. Now, each object in that PLM definition, when we consume it downstream, we can have a link to that object. So here's an example of some objects in a PLM. So PLM, we love trees. Everything looks like a tree in engineering. Tree structure. On the shop floor, we don't like trees so much. So we go from the tree structure to something more readable, more scrollable, but we maintain associativity. So just because we've changed the formatting and made it a little more top-down, scroll through and get your work instructions, the important thing is that we're maintaining the associativity. Now, just because you have the tools doesn't mean you're using them right. A lot of folks, or that you're using them to their full extent. You can create work instructions and still take a picture of something and stick a picture. But that's not the point. To get the true digital thread, that could be a step, you're getting closer. But to get a full digital thread, we need those objects linked so that when we get an ECN, a change notice from engineering, we can do an impact analysis and tell you which objects are changing. So that all those objects that came down, the operations, the visuals, the tool list of tools, the list of parts, are all maintaining associativity. And actually, those illustrations can open directly and from the PLM system, and that 3D content has flown through. So I got a little example here with an integration with PTC and Windshield. So you get a little feeling for how that feels in real life. So we go and we can click on the objects, and then we would bring up the viewer from the CAD viewer and the associated illustrations, right? So this is leveraging the 3D content downstream. It's not creating illustrations in another system, and if we are creating it in other systems, that we're doing it by linking to the CAD model. Yeah. And in the execution system now, every data collection, all that becomes part of your records. All that engineering information becomes a part of your as-built records too. So that it's not just planning, it's execution, and we know that every ship, every unit going out the door, what engineering level was used, what specification was it supposed to be, and what actually happened. That's a full digital thread. Now the digital thread is not complete, by the way, so I need to make a note that we're making a lot of progress in the digital thread, but there's still ways to go. So one of the things is right now, a lot of the digital thread projects are heavy on proprietary interfaces to specific products. So we're having to specialize in specific products because the use of standards, like it was talked about this morning, is still evolving. So we have standards like STEP out there, like QIF, I'll mention some. But the adoption of standards by the vendors, by the software vendors, by the customers, by you guys, the manufacturers, is still in its infancy. That's part of the journey. That we're going to move from less proprietary from more proprietary to less proprietary system and more standardized integration. So that's part of the. So let's look at maintenance, repair, and overhaul. So the thread doesn't stop in manufacturing. All those requirements need to flow from the engineering systems, from regulatory agencies into the planning of services. And we need to use that information to do our forecasting and our planning of maintenance visits. And then when the product shows up, so we go from requirements to forecast and scheduling. And when the product shows up and we inspect it, we might still have some additional work to do. And then we go into execution. We receive the assets, we inspect it. What else do we have to do? Work scope management. We execute the task. We have findings and we test. Well, all the way when we're testing, what are we testing? We're testing to those requirements, right? They need to flow from the OEM all the way through the OEM to the owner, and a lot of times to third-party services, but we need to maintain that thread. So that thread that goes all the way to the procurement, to the supply chain, but we end up in execution. When we're executing the task, we want to know the link to those requirements. And the thread is not one direction. We want to look back because we want to leverage all that history. One of the benefits is change control, but another benefit is that we can tie the real service life information of how that product is performing all the way to the engineering. And we can find out which parts of the design are performing well, which ones could use some improvements. So that loop back and the leveraging of that information for future programs, for future planning, for design improvements, and future innovation is very important. So what does that look like? What does that look like? See. The top button. Yeah, you want to... You're saying I did it? I don't think so. This thing, the battery is...
that button right there.
Oh, that's the blackout?
Yeah.
Oh, yeah. Well. Okay, sorry. Oh. Jeez, the most exciting part of the video. Okay, hold on. Let me get it right. There we go. Okay, so here's an example of a services implementation where we're going to look and we're getting that data from the logistics in, and based on the data coming in of the product, we can determine that a visit is planned and we need to create a service order for that unit that's going to come in. In this example, it's a UAV, and we're going to repair the landing gear. So we picked the right jobs. What is it? We're going to do the rear landing gear. And we end up with the work instructions based on the plan. And the visuals all the way tied to engineering and the 3D content. But we're going to kick it up a notch. And we're going to use a tablet with augmented reality. So, and the execution. So this is, imagine me with a tablet here. I put it on the unit. And I'm going to use the tablet to guide me through the process. I could not do this kind of work instructions without the 3D. So the 3D model definition is really being used to point on top of the real unit and kind of show me this is the wire harness that I'm going to need to remove, and even what kind of tool I need to use to take it out. So here's that torque wrench. You can kind of see that this keeps evolving and it keeps polishing. But here's the wire harness. That's where it goes. You get the idea of how we can leverage the 3D content all the way down line into these are the parts. These are the parts that need to be verified, serialized, what they look like. If I'm taking one part out, putting another part in, it can show me what one looks like, what the other one looks like. And then, all the way to the as maintained. We can here look at that augmented reality. It's updating the database all behind the scenes. So I didn't have to type all this information again. That information got recorded here, and I can see my as maintained, what got removed, what got installed. So in this case, I had a removal and a replace. and that serial number has replaced the old serial number. So all this maintained in the system, right? So that's a little glance, and yeah, we can print it. We can print it, but the idea is that all that data is online. And these reports are not things we're filling out by hand. It's things that we could print at any moment. More importantly for the digital thread, we want to hand over that to the customer as a digital structured information that they can fold into their systems, right? Okay. So how's that? Exciting stuff? Pretty cool stuff, right? Okay. Oh, I did it again. Okay. There we go. Sorry. That button's really ergonomically not in the right place. Let me see. Okay. So, but the digital thread doesn't stop there. So we went manufacturing, services. It really goes into that supply chain, right? So these organizations that are designing the manufacturing, how we're going to build it, they're also in designing the product. About half of what goes into that product, or maybe more, 70%, is in the supply chain. We want that handover of information to also be digital. Structured, parsable, right? Should quiz you on the tenets of the digital thread, what we want. But we want that information flowing. Now, so each layer of supplier, right, has its own processes, its own set, so that needs to be consumed from one engineering department to the next engineering department to the next engineering department. You can kind of see the chain. In a way that when I get my requirements back, I can cross-reference. When I get my data back, my actuals back, I can cross-reference to the engineering. Okay? And ideally not without a lot of manual checks along the way. So ideally, that supplier, when they're inspecting the product and verifying it, when they give me the data, that as built, as inspected information folds up into that tree. So the digital thread is not just within my organization, it's into the supply chain and rolled up, down and up. Okay? So we want to maintain that thread. And we're working a lot with standards organizations like the Open Applications Group that are working on the standardization of messages to go down and up the supply chain. Because at the end of the process, we want an as-built report, a device history records that folds all that information from all our critical units into our final assembly that we're delivering to the customer. So some resources here at iBase-t that we have on our website. I'm going to point to some, but there's one on talking about this problem and the potential solution and taking quality management to the next level, into the supply chain. So I encourage you to read that and how we are moving up. And a lot of your organizations have moved from these efficiency-driven methods of working with suppliers and just cracking the whip and lower price, please, to moving to more of a collaborative model with suppliers. The next level is all the way to an integrated value chain for manufacturing. So not only where that supplier, customer, supply chain, we're building a whole ecosystem that can deliver that full digital footprint to the end user. So what is your digital thread score? So another paper we have on the website talks about these handover things that you could do, and you could just use our spreadsheet as a starting point for yours, but I encourage each organization to really score their digital thread and start making progress and set milestones along the way. Let's look at what that looks like. So you would grab each handover and establish levels. Here in our example, we go between 1 and 4 levels of digital thread adoption, where you are starting really, if you look at your processes that were based on drawings, but still structured, all the way to leveraging the 3D models, and then all the way to using open standards. Where are you in that for the different planning definitions, for the different actuals and relating actuals to upstream data? So it is really a digital thread. And really look at your organization. Now, you might need help from different departments, right? Different silos in the organization. I mean, departments. And to fill this out, but this would be a great exercise for some of you here to really understand where the organization is at and where you have opportunities for improvement. Because what is the value of the digital thread, right? What is the value? Is it obvious to everybody else? I mean, right? It's one of the values is the fidelity of the information. Errors along the way. If we can have these better handoffs of information, more structured, more associative, we should reduce the number of errors. So there is, we should have efficiencies along the way, but eliminating errors along the way would be huge, and speeding up the process, because all those manual translations take a lot of time also into the process. So we can go from inspection to production to services, and we could evaluate organizations. Maybe services doesn't apply to you, but all the way definitely into manufacturing. And things like adoption of standards, which could be maybe even 3D PDF is a standard. If you, but ISO and STEP, ISO 10303 and the STEP standards, and there's many substandards under that. So you can go all the way there and evaluate yourself. What's next? It's the journey. It's the journey. So for example, the 3D PMI, product manufacturing information, and to capture the characteristics, the GD&T, those standards just came out. There's a QIF standard. Also, there's some very exciting things happening in the leading edge projects, right? Where we're working at taking that engineering information, taking it all the way into coordinate measuring machines, into inspection programs, into NC programs, machining programs, and maintaining that digital thread. So we continue, and there's a lot of projects you've seen where you've done proprietary solutions. Now we're taking it to the next level and applying standards. Because when we go into the supply chain, is it realistic that the whole supply chain is going to be using the same vendor, the same CAD software, the same machine vendor? That's not realistic. We need solutions that can cross, that can be multi-vendor solutions to really achieve a true connected value chain for manufacturing. So stay tuned. We continue evolving. iBase-t is one of the organizations participating in standards for digital thread and continuing to help. This is an evolutionary journey for the whole aerospace industry. So this is the place to make it happen. So a lot of resources are available at our website, and I point some to this here, but I encourage you to go to our website, iBase-t.com, and get some ebooks and white papers that talk about digital thread, about in manufacturing and services, and that's a constantly evolving place, source. Also, I encourage you to go by our booth. So we're right across here on 309, booth 309. And I just touched the surface, but you probably have more questions. So come and please visit us there. And that's what I have today. So questions?
So you mentioned about supply chain. So in the supply chain for engineering change notices, is there something in the system that's, so if there's an engineering change that comes down, will the system also look at the supply chain to say what's being manufactured so that the engineering change, so if you've got parts in work, you know, looking at that aspect of it, so you can make that engineering change effectively at some ship cut-in. You understand what I'm saying?
I understand. So the question is, where are we now? Are we handling engineering changes flowing into the supply chain today? So no. So that's part of the evolution. So at this point, we're more in tune with that within the factory, between engineering and the manufacturing system and the MRO system. Our next step is into the supply chain. And we're working with organizations like OEGI, where we're defining multiple messages, they call them BODs, where we are defining the inspection definition, relating it to the engineering information, and then a separate BOD comes and gives you an ECN. And we need to relate that ECN to all the other objects in a way that maintains the digital thread. So what's important is, what are the keys between the BOD that transmitted the model, the geometry, that transmitted maybe the inspection definition that needs to be verified along the way, the BOD that transmitted the bill of material. There could be all these different messages, and we need to relate them in terms of change control. And that is really the leading edge, the next thing we're working at doing in a very structured way. Now, if you do it all within our system, we have a solution. But as far as the digital thread that goes into the supply chain and back, we're working on that. Now, if we do have a product that if you're using iBase-t Solumina at one company and the supplier is also using it, we can connect that information to supply. But it's not realistic that the whole supply chain is going to be on one product, so we need.
So at the end of the day, EBOM to MBOM to completed assembly, does it roll up all the EBOM parts so that you look at and it can actually say all the EBOM parts were consumed, and so you have a completed aircraft?
Okay, so do all the EBOM parts for a product roll up so I can tell that a whole aircraft consumed all the EBOM parts? Yes. So, but this is important. The information in engineering and manufacturing is all associative. We try not to duplicate everything. So in manufacturing, and the manufacturing image would have used an MBOM that is associated to an EBOM. In services, it would be service bombs that are like partial segments, but they need to be related to the EBOM. So what we're working with is with partners that are creating composite apps that go and can link the information in engineering, because we have the links to the as-built, to the as-maintained, and can provide those composite views if you still want them. But and you're going to need them transitionally, because that's what we're used to. But our philosophy is actually that as you go, you enforce compliance to the engineering specification as you go, that you don't need the reconciliation processes you have today. So we want to avoid the reconciliation process and enforce along the way. But we also understand that transitionally and with the regulatory agencies, they're still going to want those kind of composite views. And we can help usually create those by going into the engineering system. I have a project with like PTC ThingWorks that goes into engineering and manufacturing and presents composite views. And there's other ways to do it. But we maintain the associativity needed for that. How are we doing on time? You still have time? So, okay. So I'm out of time, but you can get me here at the booth 309, or if I'm walking around here for additional questions. Thank you very much. Thanks for your time today.